there, welcome to mathematics class. I am Julia Alalibo, and today we'll be studying the theme algebraic operations, and our topic for today is quadratic expressions part 1. By the end of the lesson, you should be able to understand what is meant by a quadratic expression, expand binomials to produce a quadratic expression, expand algebraic expressions indirectly and directly, and factorize quadratic expressions where the coefficient of x squared is 1. Now, what is a quadratic expression? Any mathematical expression that involves variables where the highest exponent or degree of the expression is 2 is called a quadratic expression. A quadratic expression is any expression of the form ax squared plus bx plus c, where a, b, and c are integers and a is not equal to 0. Now, from this definition of a quadratic expression, we are going to use these examples to illustrate what a quadratic expression is. He said it is any mathematical expression involving variables and the highest exponent is 2. So if, for instance, this expression was 4x plus 1, then it is not a quadratic expression. For an expression to be quadratic, its highest exponent or power must be 2, and it will be in the form ax squared plus bx plus c. So examples of quadratic expressions: 4x squared plus 2x plus 1. This is a quadratic expression. 5x squared plus 25 is a quadratic expression because the highest exponent or the highest power is 2. Y squared on its own is a quadratic expression because this highest exponent is 2. 3y squared minus 6y is a quadratic expression because the highest exponent here is 2. If it were higher than 2, say 3 or 4, it is no longer a quadratic expression. Now, any quadratic expression can be compared to ax squared plus bx plus c in order to obtain the values of a, b, and c. Now, for example, from our previous examples, we have 4x squared plus 2x plus 1. Comparing 4x squared plus 2x plus 1 with ax squared plus bx plus c, we see that a is equal to 4, b is equal to 2, and c here is equal to 1 in this expression. Now, for 5x squared plus 25, a is equal to 5. b, that is the integer with x in this equation, is equal to 0 because there is no number that has just x with it. So in this expression, b is 0 and c is 25. Now, for the third expression, 3y squared, a is equal to 3. We do not have any b and we do not have any c. So b is equal to 0 and c is equal to 0. And for the last expression, 3y squared minus 6y, a is equal to 3, b is equal to minus 6, and c is equal to 0. So notice that from these above expressions, the values of a and b are called coefficients. They are the coefficients of x squared and x, respectively, while the value of c is called a constant. The unknowns, x or y, are called variables. So a is the coefficient of x squared, or y squared, as in these expressions, while b is the coefficient of x or y, as in this other expression here. So a is the coefficient of x squared, b is the coefficient of x. A, b are called coefficients, while c is called a constant term because it has no variable with it. Remember, we called x or y or any unknowns in the equations, we said they are called variables. So any term that has no variable attached to it is called a constant. But if it has a variable attached to it, it's called the coefficient of that variable. Also notice that from these equations, the value of a was never 0. Because if the value of a is 0 here, let's say we have 0x squared plus 2x plus 1. 0 times x squared automatically gives us 0. So we are left with 2x plus 1. So 0x squared plus 2x plus 1 is actually equal to 2x plus 1. And now the highest exponent or power here is not 2, rather it is 1. So this is not a quadratic expression. That is why a can never be 0, because if it is 0, then the expression is no longer a quadratic expression. So we have to note that in a quadratic expression, the value of a, that is the coefficient of x squared, can never be 0. The value of b and c can be 0, while the value of a, b, and c can be negative. That means they are not always positive numbers. They can also be negative numbers. So that is what a quadratic expression is. Now, amongst these examples, which of these is a quadratic expression? And we are also asked to state its coefficient and constant term. Now, A, v squared minus 2v cubed plus 3. Is this a quadratic expression? Yes or no? The answer is no. It is not a quadratic expression because the highest exponent is 3. B, 3v minus v squared plus 2. Is this a quadratic expression? The answer is yes, because the highest exponent is 2. Now, if it's a quadratic expression, we are asked to state its coefficients. So the coefficient of 3v here is 3, while the coefficient of v squared is minus 1, and the constant term here is 2. So this is our A, this is our B, and this is our C. Now for expression C, is this a quadratic expression, v minus 25uv? The answer is no, because the highest power is 1 here and not 2. And for expression D, 15uv cubed minus 3v squared plus v plus 9. Is this a quadratic expression? The answer is also no, because the highest exponent is 3, not 2. So for an expression to be called a quadratic expression, its highest exponent or power must be equal to 2. The expansion or product of two binomials usually yields a quadratic equation or expression. We are going to use this example to see how a quadratic expression is formed. Find the product of x minus 2 and x plus 5. Now, this is a binomial expression. This is binomial 1 and binomial 2. So to get the product, we multiply each term in the first binomial by each term in the second. What we mean by that is you take x, multiply by each term in this second binomial, take minus 2 and also multiply by each term in this binomial. So we have it here, x times x plus 5 minus 2 times x plus 5. So once we expand this, we have x times x. This gives x squared. X times 5 gives 5x. Minus 2 times x gives minus 2x. And minus 2 times 5 gives minus 10. Now, 5x and 2x are like terms, so we can further simplify this. 5x minus 2x gives 3x. So the product of x minus 2 and x plus 5 is x squared plus 3x minus 10. The next example, expand 3y minus 5 all squared. So we expand this from these points. So 3y minus 5 all squared is equal to 3y minus 5 times 3y minus 5. And just as we did in the previous example, we use the binomial in this, we use the terms in the first binomial to multiply each term in the second binomial. So we have 3y times 3y minus 5 and then minus 5 times 3y minus 5. So 3y times 3y gives 9y squared 3y times minus 5 gives minus 15y. Minus 5 times 3y gives minus 15y. And minus 5 times minus 5 gives plus 25. We have here 9y squared minus 15y minus 15y. They are like terms. Minus 15y minus 15y is minus 30y plus 25. So this is how this quadratic expression is gotten by the multiplication of two binomials. 3y minus 5 squared to give 9y squared minus 30y plus 25. Now, direct expansion. Notice that in the previous example, we had to open the brackets, use the first term to multiply the next binomial. We do not always have to do that. That is, we do not always have to expand it. We can also get the quadratic expression or do the multiplication by direct expansion. So, for instance, we have p minus 2 times p minus 3. The answer to this is p squared minus 5p plus 6. The previous example, what we did is p times p minus 3, then minus 2 times p minus 3 to give us the product. But we do not always have to do that. To do direct expansion of these binomials, the first term, p squared, is gotten by the multiplication of the first two terms in the brackets. So we have p times p. This gives p squared, which is the first term here. The last term, which is 6, is gotten by multiplying the last two terms. That is minus 2 times minus 3. This gives 6. And then the middle term, minus 5p, is gotten by the addition of the product of the inner and outer terms. That's what I mean is minus 2 times p plus p times minus 3. So this will give us minus 2p plus minus 3p, which is what we have here. So minus 2p plus minus 3p, this gives minus 5p. And that is how this middle term is gotten. So to do direct expansion, we have p minus 2, p minus 3. What we simply do is p times p, the first term times the first term, to give us p squared. Then the last term times the last term in each bracket to give us the last term, minus 2 times minus 3 to give us plus 6. Then the middle term, minus 2 times p plus p times minus 3. So this gives us minus 2p and this gives us minus 3p. The addition of them both will then give us minus 5p. And that is how we do this by direct expansion. Now, let's quickly use direct expansion to find the coefficient of b squared. So we have b minus 5 and then b plus 5. And the question is, what is the coefficient of b squared? And b squared, we know that it's going to be the first term. So we simply do b times b. This gives us b squared. That means the coefficient of b squared, from just doing this alone, we know that it's already 1. So the answer to question 1 is 1. But we can go further to get the actual expansion of the entire expression. So this is b times b gives b squared. Then to get the last term, we do minus 5 times plus 25. This gives us minus 25. To get the middle term that will be here, we can do minus 5 times b to give minus 5b plus b times plus 5. This gives plus 5b. So minus 5b plus 5b is actually 0. So we say this is 0. So the expansion of b minus 5 times b plus 5 is b squared minus 25. So the coefficient of b squared here is 1, which is what we've already gotten here. Now, what is the constant term? 3y minus 5 times 2y plus 1. The question is, what is the constant term? We know that the constant term is the third term, And we can simply get that without doing the entire multiplication, just by doing direct expansion. Minus 5 times 1. This gives us minus 5. So the constant term here is minus 5. Now for question C, what is the coefficient of CD from the question? 3C minus 4D all squared. So we can write this out. 3C minus 4D. 3C minus 4D. By direct expansion, 3C times 3C will give us the first term. That is 3 times 3 is 9. C times C is C squared. Minus 4D times minus 4D will give us the last term. That is plus 4 times 4 is 16. And D times D is D squared. Now to get the middle term, we say minus 4D. The inner terms, minus 4D times 3C plus 3C times minus 4D. So this gives minus 12CD plus minus 12CD. Because 3C times minus 4D is minus 12. So minus 12CD plus minus 12CD is actually minus 24CD. So the inner term here is minus 24CD. That is, the question is, what is the coefficient of CD? That means the coefficient of CD is minus 24. Now, to factorize a quadratic expression means to break down or reduce the expression into its factors and then express it as a product of those factors. A quadratic expression, just like an ordinary number, can have factors. Now, for instance, the number 6. 2 times 3 gives us 6. So we can say factors of 6 are 2 and 3. X squared plus 4x plus 3 is equal to x plus 1 times x plus 3. So we can say x plus 1 and x plus 3 are called factors of x squared plus 4x plus 3, just as you would say when using ordinary numbers. Now, prime numbers do not have factors apart from itself and 1. Similarly, some quadratic expressions also do not have factors other than themselves and 1. Some examples are x squared plus 2x minus 7, x squared plus 10x plus 12. Now, how do you know when a quadratic expression does not have factors, or how do you know that a quadratic expression is a prime quadratic expression? We are going to see that as we go further. Factorizing a quadratic expression, just as we said that, just as ordinary numbers have factors, quadratic expressions also have factors. Now, to factorize a quadratic expression means to break it down and express it as a product of its factors. So when we are told here, factorize x squared plus 8x plus 12, what we are being told to do is to make x squared, express it as a product of its factors. So the solution is to fill the bracket where x squared plus 8x plus 12 is equal to something like this, with terms inside the bracket. Now, to factorize x squared plus 8x plus 12, the first step, we look at the first term in the given expression. This is the given expression, x squared plus 8x plus 12. The first term is x squared. So the first thing we do is fill up the first term in each of the brackets with x. So x squared plus 8x plus 12, we simply fill the first terms with x and x. This is the first step to factorization. So we know that the first terms in each of the brackets, because this is x squared, and remember when we were doing direct multiplication, to get the first term, we did the first term times the first term here. So if this is x squared, it means that what should be in the bracket is x here and then x here. Now, the second step, remember our question is x squared plus 8x plus 12. And we've said that the first term in the bracket, we've said this is x here, and this is also x here. Now what we are left with is to find the remaining terms that will fill up this bracket. So the second step, consider the last term in the given expression. The last term given was 12. Not just 12, but we also have to consider the sign plus 12. This means that the product of these two last terms here must be plus 12. Remember from direct expansion, when you want to get the last term, you multiply the last two terms to get the last term here. Meaning that whatever will be in this bracket, this last term, must be such that its product will be plus 12. Now, so we'll consider possible pairs of numbers whose products can give us plus 12. So the possible pair of numbers are plus 12 and plus 1, minus 6 and minus 2, minus 4 and minus 3, minus 12 and minus 1, plus 6 and plus 2, plus 4 and plus 3. All these pair of numbers, if we multiply them together, their product will give us plus 12. But we have to choose a number that will best fit or suit this equation. That takes us to step 3. In step 3, the quadratic expression we are considering is x squared plus 8x plus 12. And now we've gotten that what should be in this bracket here is x and then x. And we're trying to get the remnant, what is left that will be here. Now we said to get what is in this bracket, the last terms here, we look at plus 12 and the possible pairs of numbers to give us plus 12 from the previous step, step 2, they are plus 12 and plus 1, plus 6 and plus 2, plus 4 and plus 3, minus 12 and minus 1, minus 6 and minus 2, and minus 4 and minus 3. This entire pair of number could give us plus 12. But that is not the only criteria to consider when looking for the last terms. We also have to consider plus 8x. Now, the third step, consider the coefficient of the middle term in the expression. For us, it is plus 8. This means that the sum of the last terms in the bracket must be 8. That means this pair of numbers have two conditions to fulfill. First of all, their products must be plus 12. Then their sum must be plus 8. So amongst all these pair of numbers, we look for the particular pair whose sum is plus 8, knowing that for every pair of numbers, their product is plus 12. So plus 12 plus 1, this gives 13. So this is out of it. Plus 6 plus 2, this gives us 8. This plus 6 and plus 6 will fulfill this condition of giving us a product of 12 and a sum of plus 8. If we want to go further, check 4 and 3, this gives us 7. It doesn't fulfill the condition of plus 8. Minus 12 and minus 1, this gives minus 13. Each sum gives minus 13. It doesn't fulfill the condition. This gives us minus 8. Minus 6 and minus 2 gives minus 8. It also doesn't fulfill the condition. And the same goes for minus 4 and minus 3. This gives us minus 7. It also does not fulfill the condition. So only plus 6 and plus 2 would totally satisfy the condition for this expression. So we can simply impute plus 6 and plus 2. So to factorize x squared plus 8x plus 12, we have that x squared plus 8x plus 12 is equal to x. Now we impute the first number, plus 6, bracket open, x plus 2. You can always check to see if you're correct by expanding this. If you expand this, you will surely get this. This tells us that this is the correct factorization of x squared plus 8x plus 12. Thus, x squared plus 8x plus 12 is equal to x plus 6 times x plus 2. Now note that if the last term and the coefficient of x is positive, we consider only positive factors. In the previous here, notice we considered both positive and negative because it was the first example. But if the coefficient of x and that of the last term is positive, there's no need to consider the negative factor. We consider only positive factors. Another example, factorize p squared minus 7p plus 10. Step 1, we open our brackets, we look at the first term in the expression. This is p squared, so we just simply impute p and p. Now, we have to look for two pairs of numbers such that their product gives us plus 10 and their sum gives us minus 7. So the possible pair of numbers, plus 10 times 1 will give us 10. This is the product. We have to look for products that give us plus 10. Plus 5 times minus 2 also gives us 10, so it satisfies the condition for plus 10. Minus 10 times minus 1 gives us plus 10. It satisfies the condition. Minus 5 times minus 2 also gives us plus 10. It satisfies the condition. But step 3, which we are combining together with step 2 for this question, the sum of these factors must give us minus 7. So we have to look throughout these factors to see which of them sum will give us minus 7 as the answer. So plus 10 plus 1, this gives us plus 11. So this makes this condition not to be satisfied. Plus 5 plus 2 gives plus 7. We are not looking for plus 7. Minus 10 plus minus 1 gives minus 11. It doesn't satisfy the condition either. But minus 5 plus minus 2 is minus 7. So this satisfies the condition for plus 10 and minus 7. So since we already have p in the bracket, we then fill the remaining part of the bracket with minus 5 and 2. So p squared minus 7p plus 10. To factorize this, we have p minus 5 times p minus 2. We can also expand this to see if we are correct. So let's do the expansion here. P minus 5, P minus 2. P times P, this is P squared. Minus 5 times minus 5, this is plus 10. Then we do minus 5 times P is minus 5P. P times minus 2 here is minus 2P. Minus 5 plus minus 2p gives us minus 7p. And we've gotten the original expression that was asked here. So p squared minus 7p plus 10 is equal to p minus 5 times p minus 2. This is the complete factorization of the given expression. Now, another example we have here, factorize t squared plus 5t minus 6. Our first step is to consider the first term in the expression, which is t squared. So we just put t and t in the bracket, the two brackets. Step 2 and step 3 collapse together. Find two numbers whose product is minus 6 and sum is plus 5. So we consider the possible factors that will give us minus 6, and they are minus 6 and plus 1, plus 6 and minus 1, minus 3 and plus 2, plus 3 and minus 2. Now these four factors, their product is plus 6. But what we have to contend with now is, will their sum be plus 5? We have to find the particular pair whose sum is plus 5. Now minus 6 plus 1, this gives us minus 5, and that is not what we want, so it doesn't fit. Plus 6 and minus 1, if this is added together, plus 6 plus minus 1, this gives us plus 5. So we just stop here. This is what will satisfy this condition, plus 6 and minus 1. So we simply say t squared minus 5t minus 6 is equal to t plus 6 times t minus 1. And if you expand this, you notice that you get t squared minus 5t minus 6. Now note that if the last term is negative, that is, the last term is negative minus 6, and the coefficient of x is positive, we consider combinations of negative and positive factors. That is to say, if the last term for the expression which you want to factorize is minus 6, and the middle term is plus, positive, while the last term is negative, you have to consider negative and positive combinations to get the correct answer that will satisfy the condition. Now moving on to our next example, factorize b squared minus b minus 20. Now our first step is to write out b after considering the first term. Now we look for two numbers whose product is minus 20 and whose sum. Remember, the coefficient of b here is actually minus 1. So this can be minus 1b. So we say find two numbers whose product is minus 20 and whose sum is minus 1. So we consider the possible pair of numbers that can yield minus 20 as the product. So we have minus 20 and plus 1, plus 20 and minus 1, minus 10 and plus 2, plus 10 and minus 2, plus 5 and minus 4, minus 5 and plus 4. Now all these pair of numbers, their product is minus 20. So we consider the sum, which one of them will give us minus 1 as the sum. Do minus 20 plus 1, this gives minus 19. So it's wrong. Plus 20 and minus 1, this gives us plus 19, also wrong. Minus 10 and plus 2 gives minus 8. This is wrong. Plus 10 and minus 2 gives plus 8. This is also wrong. We have plus 5 and minus 4. Adding both of them together, this gives us plus 1. So this doesn't satisfy. And we have minus 5 plus 4. This actually gives us minus 1. So the pair of numbers that satisfy this condition is minus 5 and plus 4. So to factorize b squared minus b minus 20 will be equal to b minus 5 times b plus 4. Now in summary, we looked at what a quadratic expression is and we said a quadratic expression is any expression with a degree equal to 2. It is of the form ax squared plus bx plus c. To expand an expression in the form a plus b times c plus d is to multiply each term in the first bracket by each term in the second bracket. And thirdly, we learned that to factorize a quadratic expression ax plus bx plus c means to write the expression as a product of its factors by finding the values m and n. Those are the factors such that ax squared plus bx plus c will be equal to a plus m times a plus n. And this brings us to the end of our lesson. Before we conclude, let's see some test questions to see how well we understood the lesson. What is the coefficient of m squared and m in the expression 5m minus 4 times 7m plus 2? A. 35 and minus 28. B. 28 and 10. C. 20 and minus 18. D. 35 and minus 18. So we can do this by direct expansion or by indirect expansion. But to make it faster and easier, we just do direct expansion to get the values of the coefficients of m squared and m. Now, by direct expansion, to get the coefficient of m squared, we simply multiply 5m by 7m. 5m times 7m gives 35m squared. To get the coefficient of 7m, we multiply minus 4m by 7m and also multiply 5m by 2 and then add both of them together to get the coefficient of m. So we have, let's call this plus, bracket open, minus 4 times 7m plus 5m times 2. So when we do this, we have 35m squared plus minus 4m times 7m gives minus 28m plus 5m times 2 gives plus 10m. And then to get the last term, we simply multiply minus 4 by 2. Minus 4 times 2 gives minus 8. Now simplifying this, we have 35m squared minus 28m plus 10 gives minus 18m, then minus 8. So the coefficient of m squared is 35, while that of m is minus 18. So the correct option here is option D, 35 and minus 18. Now test question 2. Factorize 18 minus 9a plus a squared. Now notice that this is not arranged as per usual. The usual way it's arranged in the form ax squared plus bx plus c. So what we simply do is rearrange it in that form. So we make, say, a squared minus 9a and then plus 18. Now to factorize this, simply put our bracket. Consider the first term, a. So this is a and this is a. Now we look for two numbers whose product is plus 18 and whose sum is minus 9. Two numbers whose product is 18 and whose sum is minus 9. So let us consider 6 and 3. The product of 6 and 3 is plus 18, but its sum is plus 9. And we want minus 9, not plus 9. So we consider minus 6 and plus 3. If we consider minus 6 and plus 3, the product will become minus 18, while the sum will be minus 6 plus 3. This will be minus 3. And that is not what we are looking for either. So let us consider minus 6 and minus 3. Now, the product of minus 6 and minus 3 is plus 18. 6 times minus 3 is plus 18. While its sum, that's minus 6 plus minus 3, gives us minus 9. So this minus 6 and minus 3 would best fit into this equation. So we just simply say a minus 6, a minus 3. And this is option C. So the correct answer is option C, a minus 6 times a minus 3. This brings us to the end of our lesson for today. I hope you understood it. Thank you. Have a nice day.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.